In this video, I'll talk about a few of the different ways we can represent functions. Okay. Before we do that, though, it's always a good idea to identify which variables in your problem are the independent variables and which are the dependent variables. Okay. And we said the other day that the independent variable is represented by x and the dependent variable is represented by y, and that's really the most important thing for us to get from this. So another way that I verbalize this is that x changes y. The x variable is changing the y variable. Okay, so if we look through this here, it says identify the independent and dependent variables. So first off, it says on day 1 there were 170 students absent from school. On day 2, 120 students were absent from school. On day 3, 90 students were absent from school, and on day 4, 60 students were absent from school. Okay, so we're going to identify the independent and dependent variables. So, to start off here, obviously the two things that are changing, one thing would be the day. So one of our variables here is going to be the day, and the other one is going to be the number of students absent. Okay, so we have the day and the number of students absent. And we have to look at this. If we think about this like x changes y, is the day changing the number of students that are absent, or are the number of students absent changing the day? And it kind of made more sense the first way I said it. The second way didn't make a whole lot of sense. So since the day, x, is changing the number of students absent, y, then we know that x represents the day and y represents the student absent. So the day then would be our independent variable, and our dependent variable, or the y variable, will be the number of students absent. So this would be the dependent variable. Okay. Now, if we're writing this data in a few of these multiple representations, we'll start with an ordered pair here. To write this as a set of ordered pairs, what we first need to recognize is they could have told us this in any order. They could have said, you know, there were 178 students absent on day 1. Instead, they said on day 1 there were 170 students absent. It's important for us, though, to make sure we put this in the right order. And to do that, remember that the x, or the day, should always come first, and since we identified y to be the number of students absent, that should always come second. So it only just by happenstance works out that they are going to be in this exact same order that they have them in the problem. So to write them as ordered pairs, again, I'm just going to list out all of our different ordered pairs here. We got 390, and then we have 460. Okay, so now at this spot, let's go ahead and look at a graph here. A graph would look something like this. This is just going to be a real quick sketch. I'm not going to get too detailed with this. But on the x-axis, we should be talking about the day. So I'll put day down here. And on the y-axis, we should have the number of students absent. Abbreviate students here as STU. So the number of students absent and the day. And for the days, it looks like, since we're just going up by 4s, I'm just going to have each of these count for 1. So I'll have this go 1, 2, 3, and 4. Now for the number of students absent, I should probably go up by something a little bit bigger than 1s, or I'm going to be here for a while. Since the highest one is 170, I think what I'll do is I'll go up by 50. So I'll make 4 little lines here. That would put me up at 200 right here. That would make this 100. And then each of these in-between lines would be 50. So this would be 50 and 150. Okay, so let's first graph the point 1, 170. So that point, if I graph this ordered pair, would be right about here. Okay, and now if I graph the point 2, 120, that'd be, you know, somewhere in between here. It's not going to be a perfect sketch, but it'll give you an idea of what it should look like. 390 would be somewhere in here. Oops, kind of went a little too far over. Let me fix that. There we go. And then finally we have 4 and 60, which would be just a little bit above that 50 line here. Okay. So we're not going to connect the dots here. We're not trying to create a graph or a line like you might be with some graphs, we're just going to create ordered pairs for this, dots. They haven't given us any kind of middle information, and it doesn't make a whole lot of sense to connect the dots. On day 1.5, we wouldn't really think of how many students would be absent on day 1.5. So we'll just have dots for this. Now, one more thing that I'll add here, I'll add a C. We'll call this a mapping. You may see that, or a table even. Tables I'm going to assume you guys are pretty good with. But for a mapping, what you do is you usually just list out in one grouping, you put all the X variables, and in the other one, the Y, you put all the Y variables. Not always, but sometimes they'll make sure these are in order, so they'll list them from the smallest to the biggest. So here I'd have 60, 90, 120, and 170. You don't have to do that, but some books or something will always make them go from smallest to biggest. So now what we're going to do is just connect the dots here. So on day 1, there were 170 students absent, so we'll draw an arrow here. On day 2, there were 120 students absent, so we draw an arrow here, and you can kind of see the pattern that each of these would be connected as you go. Okay, so that's just a bunch of different representations you could look at with a function. You've got your independent and dependent variables help you tell which is X and which is Y in these ordered pairs, so we don't put them in the wrong order. And then you can sketch a quick graph or a mapping. Again, a table should be something you're familiar with. I mean, you could really just draw a quick one right here. You would just have an X and a Y, or if you, instead of listing them as X and Y, you could put day and students absent instead of the X and the Y.